Okay, so what I will do, I'll start with you, Jernice, and you're going to do a quick introduction, and maybe if you can just tell us what you're doing in Singapore, how did you end up with a CQV background, or what is your CQV background, and then we're going to go to the next one.
Hi everyone. First of all, thank you for inviting me to this panel discussion. My name is Jernice. I'm actually from Lonza, Singapore, but I'm actually part of the global engineering team supporting digitalization of the CQV program for the company. So my background is mainly, well, I started my career in Schering-Plough. I think as a lot of people from Singapore in the pharmaceutical industry also started from Schering-Plough. So my career actually started with quality as well as QC roles, and then slowly I moved on to engineering roles, mainly with commissioning and qualification as well as validation. So that's kind of the background that I have. I have been involved with several greenfield as well as brownfield projects. One of which is a $200 million USD project in Singapore for a brownfield expansion project.
With your experience, Naz, that's you.
Hi, my name is Naz. For me, I started off my C&Q career with client side. I was a consultant previously, so actually my background, when I started off, I was doing a lot of commissioning work. And then I moved on to the user role as well, so I have a mix of both aspects. And C&Q also, because as a consultant, I was exposed to a lot of C&Q activities, doing clean utilities, process equipment qualification, and also instrument qualification as well. That's about it from me.
David?
Yeah, Dave Margetts, I'm CEO of Factorytalk and Batchline. We focus more on digital solutions. I'm going to take more of that part in this panel, I assume. And I started in industry, but also in systems engineering validation at AstraZeneca in the UK, at Macclesfield site. I was lucky enough to be brought up in that area, so it was kind of like a little bit like in the old days. There was a coal mine, and most of the people at that town worked in that coal mine. So a lot of people in that area worked at AstraZeneca, and I had the chance, even at high school, to do work placements there, and I ended up there before university and after university, and finally I moved to Asia. I started quite early on in installing, configuring, commissioning systems in different parts of the site that do a wide range of manufacturing process. And then in Asia, we've been focusing on digitalization, so a lot of MES system deployments, not just in Asia, but around the world. ERP system validation of all types of systems really, and for small companies, large global companies, we're involved in rollouts of systems across the whole world currently from our base in Thailand and the UK. So yeah, that's me and how I got into this.
Nice. So I think we have a diverse panel, and David, I will look at you to moderate, and anytime we talk about game-related topic and things like that, and help us there. And I think it represents a little bit what C&Q is about. It's a bunch of people that work together in order to define and test equipment. The first things I want to ask you is, when you are in a C&Q project, right? What defines having a good day for you? When do you go home in a C&Q activity and you say, that was a good day? So who wants to take this one first? Not easy to have a good day in C&Q.
I think from C&Q perspective, every time we go to work, we expect to go back with a good day. Unfortunately, that's of course not the case. What defines to me a good day is that we go into the, especially during the C&Q execution phase, where you go into the day and then you come up resolving the issues that has been identified, right? Because the main thing for C&Q, like you said, is about making sure that your facility, your utilities, equipment and systems are actually tested properly. So, of course, we are not expecting it to be 100% that it will always pass. But the important thing is, we know what's the problem, we resolve it, and then we go back saying that, hey, that particular piece of equipment has been qualified correctly, so that we can ensure that, you know, the product that's going to be produced is safe, of quality, and of efficacy for the safety and health of our patient. So,
Can I add as well?
Sure, please.
Okay, so I also feel that collaborative approach, you know, between teams like engineering, quality, QA, QC, and I think that as to have C&Q, to do C&Q, we need to work together. I feel that if you work together as a team, the work will get done better. You know, there's a lot more collaborative approach within the departments. So I feel that to have a good CQV, you know, is more of a collaborative approach as well. Yeah.
David, what is a good day for you?
It's a very good question. I think in a software context, right, then I just came out of doing the 2-day GAMP training here in the start before the conference, and we made the point that in software testing, a good software test, or let's say we try to find issues that haven't been seen, right? We're trying to find issues that we didn't know about, right? And so in a good day, on the one hand, we find a load of problems with some software, right? And then that's also a bad day because we're going to have to fix those problems. I think for me, the good day is when we find problems. Of course, we can fix them quickly, but then we don't see those problems come again, right? So the good day is when we find software problems before they go out to be used in commercial GMP environment, because they can be problems with data and data integrity, and they can be highly significant, right? And it's a good day when we catch those issues, and you're probably going to ask that next, but a bad day is when we find the same issues again, or issues in the same functions in the same software. That's very frustrating and a sign of poor quality software development, right? So good days, we find problems and we find the new ones and we can solve them quickly.
Yeah, so you asked the question, now you have to answer, what is a bad day? Yeah, go ahead. We bounce back the question.
Okay, for me, a bad day, if I'm behind time, if I cannot commission and qualify the system on time as per schedule, so, and we don't have enough resources, for example, or even, especially schedule, we are not meeting timelines and costs, that's what I think, in my opinion.
Well, I kind of agree with what David says, right? A good day is when you go to work and then you find out issues that you can resolve. A bad day goes in and then you find that the issue that you discovered a week ago occurred again. Whether it's because of an equipment failure, or most often than not, it's unfortunately it's due to a human factor. And then you realize that, hey, we found that issue with a particular that was flagged out in a particular incident with someone maybe not doing the testing properly. And then 2 weeks later, you find another incident where, the same thing occurs. So what have we done to ensure that even in the project phase that we don't meet with recurring issues like this? Of course, we're not saying that in C&Q you want to actually trend recurrence of an incident, because that's going to be difficult, right? But I think a proper control of your project quality system is pretty important. You need to have people who knows what they're doing, and then if there is issues that pops out, that you actually have lessons learned that share with the team. So the worst thing that always happens is going to the day and then realize that, hey, something that we had and we already discovered occurred again. That means that we haven't been doing our job, trying to control the entire project quality systems.
I think in both of your answer, you're talking about teams, right? When how good is the teams and sharing this team. I don't know where I read somewhere that why should we learn from our own mistake, right? I think what you're saying, like sharing the mistake of others so that we can learn from them without making the mistake, especially in C&Q and things like that. It's a good way to level up the team, right? But it also requires that there is no blaming game, right? And it's a very contractual that the CQ, when you talk about cost and schedule and taking the time to do those lesson sharing and adoption is one of the challenge I can see. So if you had to share like one moment in your whole CNQ career where there is something, a practice or something you do that you discover that say, oh, that helped me in my job, that eventually we can share with others, and you say, that's something I do because it helped me to deliver my job. Can you think of something? It's either a document you read or a practice that you have in your project to, kind of give the assurance that we're going to have a good project. I give you, for example, as an example, to answer to my own question. For me, the things I prefer to do when I do a CNQ project is to freeze the system list. I hate to go in any project if that system list is not frozen, because I know that we're going to have endless debate on resource, we're doing accountability and things like that. So one of the things I do when I do a CNQ project is to ask the system list and ask who own it. So do you have CNQ in general, right? Not only execution, but Dave, you have when you start a software testing, or is there a thing that you say, if you have that foundation right, you're more likely to be successful?
Yeah, it's a great question actually. I think, or maybe I'm interpreting this more like a watershed moment, I would say, right? So definitely recently, we have now GAMP 5 second edition, CSA, that came out at the same time. And one of the best chapters for me in GAMP 5 second edition is the Agile section, right? And let's say the reality of pharma industry realizing that we can't inflict our terminology or our approaches that are quite legacy on modern software development, right? Because of course they are, modern software development has advanced so fast. And they're doing the same things, right? You have requirements to software, you have to develop it, you have to build it, you have to configure it, you have to test it. But this is now highly automated and they work in an agile fashion, right? And an agile methodology is not only a technical topic, it's a way of working, right? So, and that's something I would say has been a watershed moment for me and for us, is being involved with, we had to evolve, our company had to move into agile methodologies, test automation, software development lifecycle automation. And now I can see by understanding that and how those tools and how those engineers work and how those engineering teams work, I can see that should be the future of computer validation, right? And so it's quite hard to train actually today in CSD, because on one hand we've got this kind of it's difficult for people who are new to understand a static document approach to validation. Right? We have to do a lot of training just to understand that. And on the other extreme, we've got companies and organizations and software products that are they're created in a highly automated way. They don't have any documentation, let's just say. All of the evidence is within systems. It's completely inherently traceable. They can use the requirements for new designs and test those overnight with hundreds of automated testing whenever there's a change, right? And that's the other spectrum of where we are with computer systems validation, right, which is huge. So it's a very exciting time to be involved with CSD, and we've got a challenge with AI ML coming along now. How are we going to do with that? Certainly not with static documents, but yeah, watershed moment was us realizing we need to move to automation, we need to move to agile ways of working, which is not only you said very well, not just the tool and the method, right, but the agile methods. I've seen our company and our people improve the way that they work dramatically, right, and we learn from that. So when I see the daily stand-up meetings they do, at the end of every sprint, the sprint retrospective, this continuous improvement is hard-coded into the way that software engineers think today, and how they're trained in school. And I think that's really impressive, and it's something we can really learn from. Right? And I think that, for me, that's the right way. And I think it's great to see GAMP and even US FDA understanding that and talking about that. So for me, that's a watershed moment.
Do you want to share something, or you can skip any of my questions? It's okay.
I can only say that CNQ has a lot of documentation. It's a killer. So if I can get rid of or improvise The documentation, CNQ documentation, I would do that. Yeah. Apart from paperless, if let's say that we don't have paperless, we still have paper-based. We can actually streamline the testing requirements. Make it simple. Because I've seen in previous client sites experiences, some documentation can be really massive and takes a lot of time and resources and effort. So if we can streamline this, I think it will be good. That's my point.
CNQ strategy. I think going into a project, knowing and defining a clear CNQ strategy is, to me, something that would be very important at the start of the project, because the CNQ strategy basically would drive what are the deliverables you want. The system list, of course, is very important also, because if you have a continuously changing system list, it means that your resource loading, your schedule, everything is going to be impacted by it. But also what's impacting is what is the strategy that you're going to adopt. Are you going to say that you're going to leverage on commissioning or even SAT testing? Or are you going to say that I'm going to just do in-house commissioning testing, and then qualification will all be leveraging only on in-house commissioning testing? So this kind of strategy affects a lot about resource planning as well as schedule planning. So to me, at the start of a CNQ project, when I first get the project initially, that's something that I want to have it defined very clearly first.
Yeah, and the CNQ strategy is also a challenge, because in a project you have a lot of construction company which we're going to leverage, automation and software, and we have vendor, and they all come with their own way and knowledge of how they do CNQ, right?
Yes.
So one of the challenges when we have that fantastic strategy that internally we all agree is to get those people that might be there for 3 weeks for SAT and things like that to plug into our strategy, right?
Actually, one of the other things is also that the CNQ strategy, I think conventionally, a lot of times we try to define the CNQ strategy a little bit too late in the project. Because if you think about when a project is first initiated and then when front-end engineering is actually taking place, that's really when they are doing the design of the equipment and trying to source for vendors and putting out the technical requests as well as specification to the vendors of what is needed for eventually for the equipment to be procured. So as part of this, right, with the CNQ planning, if it doesn't take place early enough, it just means that when we want to start doing verification of very simple things, vendor documentation, you might not get the documentation because it wasn't planned up front. You haven't communicated to your vendors. It wasn't part of the procurement process. So you end up going in trying to chase the vendor at the point of time where they've already done the FAT, SAT, they're no longer so committed to providing you with documents that you need. Of course, we talk about CNQ, there's a lot of documentation, yes, but some of these documents are actually pretty important to prove, for instance, what's the material that they use, whether it's fit for intended use of the equipment. So if you do this CNQ planning as part of early on with the engineering folks, to make sure that the requirements that is needed for eventual CNQ testing is also inside, then it's a little bit easier instead of subsequently trying to rectify the issue.
Anybody want to add to that? Or? Okay. Now I'm going to ask you. I'm going to share an example, and so you can think of what is the ugliest example you have seen in your CNQ career. For me, the worst I thought is. I'm going to go back to that autoclave. We buy an autoclave, install the autoclave, IQOQ the autoclave, and the autoclave is working like a charm, right? Not many punch items, very good vendor. We go in PQ and we do the first run, and the autoclave takes something like 48 hours to cool down. Well, we didn't buy a liquid autoclave. So we went all the way to PQ to realize that it wasn't fit for intended use because we had a saturated steam autoclave, and what we need is an autoclave with air pressure. So you really wonder how can we go so far into doing IQOQ commissioning and realizing after months of work that there were absolutely no value in what we have done because it wasn't fit for intended use. And it really came down to that communication, right? It's the fact that the user requirements were written in bit like, we need an autoclave to tick all the box, and we never really went to ask the user, what are you going to put in that autoclave, right? And that, it's not for an Asian company somewhere, it is for a big multinational, big project and things like that, and the only choice you have is to change the autoclave, right, at the end of the project. So that's one of the worst days I saw, where you really say, how can we, with all those, and I think, it was in the early age of my, like 2004, 2003, and I think all those design review and formalization in DQ are things that sometimes could be like a lot of documents, right? But then had to mitigate those kind of things, which then your schedule and timing and goes completely to those. So do you have a case like that where something that really went bad, and you say, what should we have done differently?
I could probably be here too long for that one. I'd say one of the many bad experiences. Right, we often get asked to help solve these problems after they blew up, and then you sometimes really wonder how did we get to this point, and it can be very surprising, right? So I've seen projects that should have been stopped earlier, clearly, right? So, going live with a new ERP and a new MES and a new LIMS, one of the biggest sites in Europe on the same day, you would expect not to be a good idea, right? And then if you see the extent of some of the actual issues, it can be highly surprising, right? So we have to do better, clearly, right? And introduction of a new IT system should not lead to stock outages, right? It should not slow or stop a production, and I've seen that happen, unfortunately, right? So then you really have to question how did we get that far, right? And the difficult thing is software can be very, very complex. So even one of those systems alone, or even part of one of those systems alone, can be highly complex and take a long time to set up, configure, test, and then can you really simulate pulling that all together and then using it on day one, right? So I think that's a huge challenge in our industry, that when we take on these enterprise system projects, the reality of how will it work on day one in the manufacturing plant with the people and the actual materials and the orders, you can't really simulate that, right? So when you think about a performance qualification or requirements testing, at some point you're going to know when it hits the ground in the factory. And so we have to do really our best work to make sure that the testing and the training is extensive enough so we don't have those problems. And sadly, pharma IT projects don't have a good reputation, right? There's been many where unfortunately, it can stop production, it can cause issues, it can cause quality issues, we can have recalls, we can have all of these things happening. And so, CQV, we have to improve, we have to get better. And things like automation and AI hopefully will allow us to save more time so we can design and test these things more extensively, right? So to talk about CSA briefly again, and you could critique a lot as well, but they talked about 80% documentation before, 20% testing. One of the goals of FDA was to say we should be doing 80% testing and 20% documentation, right? And that would help us to find more issues and to reduce the risk of these some of these disaster projects from happening, right? So I've unfortunately seen these bad cases, and it puts a really spotlight on why we need to do a good job in this space.
You have an ugly story to share? Something that you can say it's a colleague, right? But to your point is, it's like that autoclave, right? And that amount of paper, we end up losing the purpose of why we're doing testing, and testing becomes a compliance game rather than trying to find really if that equipment is working or not, right? Sometimes I feel that I'd rather play with the autoclave for a week right, to see everything, then following a protocol where, you know, everybody knows that that autoclave will do it. And if there is something wrong in that, there is really something wrong with the manufacturing system of the autoclave, right? But it's like trying to test that fit for purpose. And I think, from what I understand about CSA, is going a bit in that off script and, you know, trying to really and in the physical world, we are very, very much constrained to a series of tests. And although we do the risk-based approach, we're not quite sure that the amount of tests we have done is sufficient or it's right? And unless it's a very common piece of equipment. But sometimes we spend more time doing all those. Whether they fail or they pass is not like I understand the material cert, but for me it's not in an IQ that you check a material cert, right? That's the finite stage gate where you die it must be there. But if the guy didn't order the plate with the material cert, well, from that on you won't have it, right? And you're just going to excuse not to have it, right? So I don't know if any ugly part of CNQ came to mind.
Yeah, probably an example is really to do, again, it's to do with vendor documentation. It's always about the front end involvement of CNQ during procurement process, right? You engage a vendor that you believe is a qualified vendor based on his historical, historical reasons, or it could be because other sites are using that same vendor, and then you select them. So with the basis that, okay, since they've been providing equipment to other sites from your company, they should be then, understand what is the requirements in terms of CNQ. So the case that we had was that obviously they had the other thing to Matthias is the well logs. They had well logs that has dates that were, so the inspection dates was actually earlier than when the welding dates were. So it's an obvious red flag, right? To say that, hey, what's wrong with this? How can this be ever possible? So at the point of time, the equipment is already on site. Does it mean that you have to start looking and do all your 100% inspection of the wells? Or do you actually do a risk assessment and say what is actually impacted? Do we question everything, or do we do a thorough visual inspection? So there is this kind of discussion that needs to be made, and then it's really again back to your risk assessment and seeing what is actually required, all in the phase that we need to make sure that the welding is actually integral. So does it mean that you have other forms of trying to test that the wells are okay before you actually continue with your CNQ? But again, all these things comes because you find something wrong with documentation. So even though the documentation part of it is always very heavy, and we always think that document checks are just document checks, but again, that's really the point of time where you realize that some things might be wrong, and it could be actually seen from the documents. So that's something of an example that that I'm thinking of. So eventually we did resolve the issue. I'm not going to say how we did it, but we did resolve the issue. But again, it involved a lot of resources and a lot of discussion and a lot of debate with whether it's engineering, the vendor, or the quality to say what is the correct way to go, what's the compliant way to go.
Yeah, I guess the nightmare in there is that you start to question everything you did, right? Like when those data are not trustworthy, you say, what else is real, right?
For me, what I've seen before is, for example, like during commissioning project phase, we were to commission the water systems, and it was working fine, but after user takeover, and there was problems in the system, and then we realized that we have to mitigate and install another equipment to help improvise the quality of the system. So I think that my point is, I think we should like during project stage, right? We should have a user input, like what you say, your URS. We must have user perspective or recommendations in the URS itself, rather than just having project to just prepare URS without any user.
That's the dream of every CQ. Every CQ is to have the user.
Yeah, but I think you can see, right? There's
there is clearly a value and we're getting there, but the big challenge is that users are the one making money, right? They are the production people, so taking them to do a project, you always have to, I feel, right, and I don't point anybody, but there is a common understanding as to right things to do, but it's very difficult to have it in reality, right? Because anything goes wrong in production, supply chain and things like that, the user go back to his user role, right? And they are never, so part of the project management institute and the PMI, acquiring the resource for your project is crucial, right? And you almost need to say, this guy is going to sit here and you can delete his email from your system because he's going to help me. Because there is always a moment it's like crazy and then they go back to production. Right? I guess for software it's the same, right? At the end it needs to be usable by the people using your ERP and things like that. So you can do the amount of tests you want. It's like the AI example I was giving, the software, and I trust you have installed enough to have gained some knowledge, but the domain application, the domain knowledge of what the software is going to be used, the same way as that autoclave, the transfer of information of the intended use is really a difficult part in the pharmaceutical world, I feel, right? Translating user requirement into engineering requirement is a very critical step for a successful project.
Yeah, absolutely. And we had a conversation in our training, or on the side of our training in the last days, where I talked about we of course have to onboard and train and develop. It's many hundreds of people, right, in the region, in the history of our company. And some of the most successful engineers and consultants we have are not computer science people. They come from manufacturing, or they come from an industry, or the pharmacists, right? They come from really pharmaceutical companies, and they can quickly pick up computer software tools, even quite complex ones. And what they have is this understanding about the reality of what happens in a production every day. And they know if they have a pharmaceutical background as well, that they have this extra layer as well. And so we're doing quite complex projects with sophisticated systems that are challenging, right? And they require very experienced resources. And some of the best people that we have really are surprising that they're not necessarily having this computer software background, right? They come and then of course they have to learn that, but they tend to, of course, they have to learn that quickly. But they bring this extra understanding, and they can talk the customer's language, right? So very quickly we can go on site, and we're doing Gemba walks, right, to look at the manufacturing process, how the software is going to be configured, because you're configuring software now generally, right, to fit it on top. They can pick it up very quickly. They can understand the terminology that the customer's using, right? They know the importance of some activities. They can also question some of the process, because they can see where parts of the process don't make sense, or it could be lean, it could be more efficient. And then, of course, they're learning the tool, how to configure that appropriately, right? But the other way around, people with a computer science background, they can pick up the tool very well. They could be very strong, of course, at the detailed programming and interfacing these technical parts. But they lose the context, or it's difficult, or it takes a lot of time, surprising amount of time to really think, what happens in a factory every day, and what are the workflows of a factory, right? So this has been one of our experiences, is finding the right people, how to train them, how to develop them, and definitely bringing people at early stage into the project, right, from our side, and also on the customer side. So we always encourage, can you get shop floor people to join the FATs, the SATs, right? As I said, it reduces your risk already, that when you hit that ground running on day one, they know what it is, and they also tell you that the way that this system is designed, it doesn't quite work like that. And the managers or other level of people in the plant that may be involved in the design discussion might not have that reality of these exception processes. So we try and really encourage, bring the operations staff as early as you can. And on our side, we try to train and develop people, of course, from both sides, but yeah, there's a huge advantage really, I think, today if you have this domain knowledge. And all of us have to learn IT systems, right? So we're getting better at picking these up.
I'm going to turn to the pigeonhole. We have a question about what are the changes in regulatory requirements for C&Q you have seen for the past 10 years, and what do you foresee for the challenge ahead, right? So, for me, the biggest change was the risk-based approach, right? That was really, and we still don't understand it. I really feel that. But we understand, like it's difficult to apply. That's the challenge, right? And to your point, it's difficult to apply because every guidance we have, and more, is to say, well, the subject matter expert will make the decision. And I feel that with the number of projects we're building, we just don't produce subject matter expert which take 5 to 10 years to mature fast enough to be able to cope with the amount of. So sometimes, what do we foresee the challenge ahead? For me is to say, should we change that approach? Can we finally recognize that we don't have enough subject matter expert and try to eventually put systems that can balance that? Do you find enough subject matter expert to do your CQ project?
When I find good subject matter expert, it's very, very useful for the project in terms of knowledge. So I agree totally, right? We said that for the past 10 years, we are saying that we are moving to risk-based approach in C&Q. We know we have to do risk assessment, and we know we want to move away from components risk assessment and going into more of a product as well as your process knowledge that fits into your risk assessment. But honestly, you have to have the right SMEs to be involved with that particular risk assessment, who has the correct product knowledge, process knowledge. Of course, also your regulatory requirements as well as your company procedures that's governing that. But oftentimes we go into a project and then, like you say, right, maybe there's no operational representative in the risk assessment. You do the risk assessment and then send it over to operational. And then, is it the right operational person with the correct knowledge to actually do the review of the risk assessment? So even though we keep saying that we are doing risk-based approach, sometimes I think it's difficult, like you say, right? The correct people to be involved in the risk assessment is actually very, very critical in making sure that your risk assessment is actually productive in identifying what are the controls you need, and then feeding that into the URS, which then you eventually do the testing during the commissioning and qualification phase. So that's, to me, the biggest challenge is to try to really be able to do a risk assessment that makes sense, and it allows you to actually identify the controls you need.
Yes, you can agree with us.
Okay, so for me, actually, just give you an example. Like previously, we had a client that wants to implement a risk-based approach, following the baseline guide. But we wanted to start from the top, like doing the PRA, and then maybe not do the SRA. But the client doesn't have the product, so we don't really know what to assess. How do you have to assess if you don't have a product? So in the end, we ended up doing the SRA, but again, we don't have the right people to actually help to evaluate the SRA, and so it's a challenging thing for us as C&Q team to actually help, and we can support, but the thing is, if we don't have the data, the information to feed the SRA, then it's very, very hard for us. So in the end, we managed to get some support from user manufacturing to help us with the SRA, and then we like what Jernice had said, we move on and do all the identification of the CDs and all those CPPs. So I think, to implement this risk-based approach, I can see the challenge there. There's no really standard ways of doing. I've seen like some projects we've done, we implement PRAs and then also did the impact assessment as part of the PRA. So it's a bit, you can actually do different than the standard approach that we normally do. So I think, yeah, so there's a lot of differences, in ways that we can do our CNQ with regards to the risk space.
I think thank you for sharing. For me, the consensus is that there is no cookbook, right? People depending on whether you're testing a software or hardware or an equipment based on your process, based on the context of your project, whether it's a product transfer, a CMO that doesn't know which product. So that's why the ISPE is also struggling to say this is how you do it, right? And everybody have agreed that all we can agree is where we want to go, how we're going to go there, is subject matter experts getting together and based on their experience and sometimes applying their knowledge and transferring knowledge in manufacturing to software testing or to equipment testing to say, this is what I want to have. So communication in those projects is key. And again, knowledge, right? Where is the knowledge? How can we tap the knowledge? How can we have the knowledgeable people for the right time, the right amount of time, so that they don't cost too much to the project, that they can have the right input? It's all part of a strategy that you need to put in place, and that required some maturity to be implemented. Do you want to add anything to this? No.
Maybe just a last comment. Gilad mentioned it in one of the previous panels, so the validation 4.0 part of Pharma 4.0, and I'm the co-lead for validation 4.0. And I think part of the reason I joined that was this kind of frustration, I would guess, but also trying to think into this future, like it talks about the future challenges. And I think for me, one of the biggest disappointments in the industry I've seen in the last 20 years is this lack of adopting QBD, right? And we talk a lot about QRM. We're going to have to move into an area of continuous QRM, almost like real-time QRM sometimes, certainly for software systems and AI ML models. And we're going to have to go back, in my opinion, to QBD principles to be able to address that. And I think that when we work in cell therapy and other areas now, and I can't really see a route forward unless we digitize with QBD principles and we get comfortable with using tools so we can do things continuously, and we can move away from subjective risk assessments to things we can really measure and use tools to measure those, right? So this is kind of why I'm in that group, and the principles I tried to, or the thinking I tried to bring into that, right? So just to also to put a little selling point for the validation 4.0.
QBD, QBD is not only for the product, it's for the equipment, it's for the software. It's like, how do you design things that are going to work instead of going in commissioning to realize it don't work, right? The idea for me, when I do a design, ideally the test should always pass, right? And that's how do you build that from the day you buy it, from the procurement time, so that the end game is that all those IQ are going to pass, right? And we're getting there. I do feel that, in the past they were doing stuff and then we were going to do an IQ. Now we've moved that a little bit more forward to say, again, with the design review and the DQ and things like that, how can we assure that the quality will be built in the equipment, in the software? Yeah, very, very important about the QBD. Okay, thank you all for listening to us. You can ask those people a lot of questions. We will have a little drink outside, so I'm sure they're going to be available.
Thank you. Thank you.
So, can we have a photo?